All right, let's finish up this section by looking at ratios. So a ratio is a comparison of two numbers, and there's three ways to write a ratio. The most common way we write ratios is in fraction form. Like if the ratio was 2 to 3, we could write the fraction 2 over 3. So if it was 2 to 3, that 2 to 3. We could write it in fraction form, like 2 over 3. We could also write it with a colon, like 2 to 3, like that. So in the following questions here, we are going to be changing the way that it looks and writing it as a ratio. So I like to write these as fractions because we use ratios in fraction form all the time. Now what's important is we have to simplify our fractions, and what's also important is that when we are making these ratios, the numbers have to be in the same unit. So once we get to a problem that's not like that, I'll explain why. So the first one is 12 ounces to 20 ounces. Well, when we're writing ratios, we could write it like this, 12 to 20. Sometimes you might see ratios written like this, and you don't necessarily need the units once you have everything in the ratio. But I prefer to put it in fraction form because it helps me to remember to simplify it. So the first number you see is always your numerator, and the second number you see is the denominator. Now, 12 over 20 can both be divided by a factor of 4. So this one would simplify to be 3 to 5. 3/5 like that would be that final answer for the first one. Moving down to letter B, 45 minutes to 2 hours. We cannot compare this in ratio form because these are in different units. So 45 minutes and 2 hours. I would prefer, it's up to you, I would prefer to just change hours to minutes, because if I change minutes to hours, this would be a fraction. Since there's 60 minutes in an hour, 45 minutes would be 45 over 60, and then you would simplify that. I would actually just prefer changing 2 hours to be minutes. There's 60 minutes in each hour. So in 2 hours, there's 120 minutes. All right, just multiply 60 by 2. So when I'm creating my simplified ratio, then this would be 45 over 120. And then I can simplify that all the way down to be 3/8 by dividing by 15. All right, moving down to letter C. Here's another one where we don't have the same units. 1 pint to 1 gallon. Well, 1 gallon is equal to 8 pints. So if I put this in the same unit, this would be 1 over 8 like that, and I could just leave the answer like that since that's simplified. If you want to try D, E, and F on your own, why don't you pause the video? Okay, let's go over D, E, and F. So 120 meters to 180 meters. I would set this up by doing 120 over 180, and then this simplifies down to being 2/3. Okay, the next one is not in the same unit. 4 feet to 8 inches. I'm going to change 4 feet to become inches. I know that each foot is equal to 12 inches. So I would multiply 4 feet by 4, and that's going to be 48 inches. So I'm going to compare 48 to 8 then. And 48 over 8 equals 6 over 1. So 6 or 6 over 1 would be the final ratio for that one. And then F, 5 pounds to 24 ounces. I know that each pound is equal to 16 ounces. So I would multiply 5 times 16, and that's going to give me 80 ounces. So I'm going to compare 80 ounces to 24 ounces. And that simplifies to being 10 over 3. So ratios can be improper fractions, they can just be regular fractions, but the most important two things is, number one, you can only make a ratio when the numbers are in the same unit, and number two, you should always simplify your final answer or it's considered not simplified. The next part of this section is comparing unit rates. So if I scroll down, The unit price of an item is the quotient of the total price divided by the total units. You can use the unit prices to determine which item is the better buy. Now this is actually really helpful when you're shopping to figure out what is the better buy. Is it better to buy this bag of apples, or is it better to buy apples per pound? So it is helpful when you're looking at this because you're going to want to save money when you have your own money and you're going shopping. So using unit prices is really helpful. So to determine which is the better buy, we're not looking for which one's cheaper. So if we're looking at a 12-ounce box of breakfast cereal for $2.79 or 16 ounces for $3.59, we're not thinking like, oh, buy the $2.79 one because that's cheaper. Like, it might be less money for that particular box, but we're looking for what is the best buy. What's the cheapest for the amount that you're getting? To do this, you would take the amount of money that it costs and divide it by how much you're getting. Not all the times are the numbers going to be in the correct order. Like, you might want to do 12 divided by $2.79, and that will work still, but your answer will be a little bit different. So let me explain. To figure out the better buy, you're always going to want to take the amount of money and divide it by whatever the units are in the denominator, because then your answer makes more sense if your answer is how much money it costs per each unit. So for this one, we would do $2.79 divided by 12 ounces. All right, and then when we do that, and we put this in our calculator and divide, this is about equal to 23 cents per ounce. So it's about 23 cents per ounce of cereal for that box. For the other box, it's $3.59 for 16 ounces. Notice that I'm including my units here so that it makes more sense to me. I didn't include the units in the other one, but these units are different. So because they're different, I'm going to include them. So should have a little decimal point here. When I do this, this turns out to being about, and I have to round, 22 cents per ounce. So now that I have these in the same unit, I'm looking at them, I can compare them because now we're both looking at money per ounce. I can see that the bigger box is the better buy. $3.59 for 16 ounces is the better buy because it's only 22 cents per ounce, whereas the other one's 23 cents per ounce. If you want to pause the video, why don't you try letter B on your own? All right. Looking at letter B, same type of deal. We're going to figure out what the better buy is. I'm going to take $2.32 and divide that by 14.5 ounces. When I do that division, I'm going to get that this is equal to 16 cents per ounce. For the second one, I'm going to take 99 cents and divide this. Oh, I should divide it the other way. It doesn't matter, but I did it this way for the first one. So 99 cents divided by 5.5 ounces. Now this says 5.5 bag of chips, but the ounces is missing. All right, so when we do that, this ends up being 18 cents per ounce. So the better buy in this one would be this, since this is the cheaper unit when we're looking at it per ounce. Now, you can do the division the opposite way. You can do 14.5 divided by $2.32. But when you do it the opposite way, please realize your answer would represent how many ounces you get per dollar. Whenever you do division and you get a final answer, that answer is representing how much of whatever per one of something else. So the denominator down here is always just 1. So this is per 1 ounce, per 1 ounce. If we flip the division the other way, please realize our answer would represent how many ounces per dollar do you get. So in that case, you would want the ounces to be larger. So I actually think that this is easier to understand this way. All right, and then the last part of this section is solving ratios. So if we flip over to the last page of 2.2, sorry, I meant to say proportions. We are going to create proportions, set them up, and then solve them. So a proportion states that two ratios are equal. So a proportion basically looks like this. A fraction equals another fraction. And there's going to be 4 numbers because we have a fraction on both sides. And we're going to be using cross multiplication to solve these. So let's read this word problem and solve or create the proportion and solve it. So you're driving from New York City to Phoenix, a trip of 2,450 miles. You begin the trip with a full tank of gas. After traveling 424 miles, you refill the tank for $40. How much did you plan to spend on gasoline for the entire trip? As soon as I see a problem like this, especially a word problem, my mind always goes to make a proportion, because proportions are always taking something and relating all of the information to solve for the missing variable. We know we're trying to find how much we will spend on gas for the whole trip. So I know there's 4 numbers here. The length of the whole trip, the gas we need for the whole trip, the amount we traveled, and then the amount of gas we needed for that travel. So I'm going to set up my proportion, which is a fraction equals a fraction. There's a lot of different ways you can set up proportions, but here's what I do. I like to relate things that make sense together. Like for 424 miles, you spent $40 on gas. So I'm going to relate that in this fraction here. 424 miles costs $40 in gas. Now, when I have my proportion set up like this, my numerator in this side will represent miles, my denominator will represent money. So looking at the last number I didn't use yet, I did not use this number here, and this number obviously represents miles since that's what it says. 2,450 miles is the whole trip, and we're trying to find out how much money we're going to spend on this trip, so the denominator will be X. Now, there's other ways to set up this proportion, like I said, but in this case, this is how I would set this up, and then to solve, I use cross multiplication. Cross multiplication means you multiply the numbers that are diagonal from each other like this. When you cross multiply, you multiply the numbers that are in the same bubble, the same diagonal. So I'm going to multiply x times 424, and that becomes 424x. I multiply 4 times 2,450, and let me do that in my calculator. I don't have that done. So 40 times 2,450, that's 98,000. And then you set these things equal to each other, and then you will have to solve a one-step equation. The last thing we would do here is we would divide both sides by 424. And then we're going to get x is equal to 231. And remember, we're talking about money. So 231.13. It's going to cost $231.13 for the gas for the entire trip. Okay, let's try the next one together. 3 cups of flour are required to make 1 batch of cookies. So 3 cups of flour for 1 batch of cookies. How many cups are required to make 3.5 batches? Okay, so this problem, we're going to make a proportion and solve it again. This problem is about flour, comparing flour to batches of cookies. So I'm just going to say flour to batches. Flour to batches. Batches is a weird word. Okay, so 3 cups of flour are required to make 1 batch of cookies. We want to know how many cups are required to make 3.5 batches. I know that the 3.5 will go down here because my units are all aligned. I'm trying to solve for how much flour we will need for this particular problem. Now it's time for us to cross multiply. When we cross multiply, we are multiplying the numbers that are in the same diagonal. So we're going to multiply 3 times 3.5, and that's 10.5. And we're going to multiply 1 times x, that's just 1x. We don't actually have to solve this at all. We will need 10.5 or 10.5 cups of flour for 3.5 batches of cookies. Okay, what I want you to do now is pause the video and try the next one on your own. Okay, let's go over this next one together. A quality control engineer finds 3 defective units in a sample of 120. At this rate, what is the expected number of defective units in a shipment of 5,000? Okay, so here is our proportion. We have 3 defective units out of a sample of 120 total. And we want to know how many will be defective with a total of 5,000 in the shipment. So here's my proportion. Again, you might have a different proportion, but as long as these diagonals are lined up, you're going to get the same answer. What I mean by that is as long as you have 3 and 5,000 in the same diagonal, and you have x and 120 in the same diagonal, then you compared these numbers correctly. When I cross multiply, I'm going to multiply x times 120, and that's 120x, and 3 times 5,000 is 15,000. And then we'll divide both sides by 120, and we're going to get x is equal to 125. So that means that there will be 125 defective units in that sample of 5,000. Okay, the very last one in this section says a tractor uses 5 gallons of diesel fuel to plow for 105 minutes. Assuming conditions remain the same, determine the number of gallons of fuel used in 6 hours. Okay, so we have 5 gallons for 105 minutes. We want to know how many gallons of fuel for 6 hours. First thing I realize is these are not in the same unit. So I'm going to change hours to minutes. I know that each hour equals 60 minutes. So I'm going to multiply 6 hours by 60 minutes in an hour, and 6 times 60 is 360. Now I'm going to use 360 instead of 6 hours because I would need to use the actual amount of minutes if I'm comparing these. So my proportion. 5 gallons of diesel fuel for 105 minutes is equal to, we're trying to figure out how many gallons we would need for 360 minutes. So this is what I would create from this information given. Now it's time to cross multiply. I'm going to multiply 5 times 360, and that equals 1,800. And 105 times x, that's 105x. To solve this, I divide both sides by 105. And when I do that, I'm going to get, not an integer, I'm going to get x is equal to 17.14. It does not say what to round to, so I'll just round in the nearest hundredth and say that it's 17.14 gallons. And that's it for this section.